So if I had a 5% glucose concentration, but it's 0.5 in the cell, and 0.9, is this going to be a hypertonic, isotonic, or hypotonic? This will, think about it for just a second.
Isn't it isotonic still?
Why?
Because the glucose is penetrating.
Because the glucose is penetrating. Which solution, so it's an isotonic solution, which solution as of current has a higher osmolarity?
The outside.
The outside. Okay. So the outside is hyperosmotic, but it is isotonic.
That makes so much more sense. Okay.
I don't think we've ever done.
Okay.
So the solution is, wait, did you say it's hyperosmotic?
What do you think? Which one has more particles?
The outside solution.
The outside solution.
Which would
Does that
be-
make sense, Manny? How? So which one has more particles? This is 0.5% glucose. This is 5% glucose.
Oh, that's what I was going to say.
Yeah.
This thing. There's point.
6. Okay. That'll
Yeah, that-
clarify. Okay.
So it was 0.9, 0.9, and then 0.5
5.
and 5.
Yeah. But so 6. Okay.
How's that?
Just to clarify.
So inside is isotonic.
So okay. What is tonicity?
Tonicity,
The measure of what's going to happen to the cell, right?
that's what tonicity. That's the definition. Oh, it's kind of the definition.
Kind of.
Okay, so I'm gonna write that down. So tonicity.
So it's what's going to happen to the cell. Is it going to shrink, blow up, or stay the same?
So
excited.
okay. So the tonicity is hypotonic, right?
Okay. Why do you think that?
Because the outside concentration is higher than the one inside the cell.
So, good thought process, but because I told you, so glucose is penetrating, okay? So as I put it in this, the glucose is going to go across until it equals out, so it has the same percent inside and outside the cell. The sodium chloride's not going to do that, okay? But the glucose will. So it's an isotonic solution because eventually it's going to be 0.9 inside, 0.9 outside, and then it will be whatever is the middle between 0.5% and 6%.
Because in molarity, the sodium chloride would break down, making more of them, right? And then glucose, it stays the same. So that's why it would just transfer over. Am I right? Or does that have nothing to do with it?
That doesn't have to do with it. It specifically has to do with me telling you that this is a penetrating particle. So what does the word penetrate mean?
To go through.
To go through. So because glucose is a penetrating particle, it can go through the membrane. Okay? So it will equal out.
Okay.
So by diffusion, by the principle of diffusion, it will diffuse until it's equal everywhere.
Okay.
Okay? But, so this is isotonic solution. But it is hyperosmotic, meaning as of current, this has more particles than this.
Hyperosmotic, right? Okay.
Okay? Is that all right?
How do we know that this is where I think I
I
may
thought there was a
get
chair
lost.
here. It's like,
Between isomotic, hyperosmotic, and
Mhm.
osmotic. How can we, like, what's the difference between isotonic, hypertonic, and hypotonic, and those?
okay.
That's where I think I was getting lost.
Okay. So,
It's like a test question. We'd be like, oh, what's that?
I'm trying to think of another way to say it without just. Okay. So this is the values that I've given you for the cell. Okay?
So that basically isomotic, hypersmotic, and hyposmotic. Basically describe the osmotic pressure that's going on inside.
Not the osmotic pressure.
No?
The osmoles. So rewind. Remember how I told you 1 mole
Right.
of calcium chloride? How many particles?
3.
3. Okay. So I'm saying the number of particles in here versus the number of particles over here.
Can I explain why I was
Yeah.
confused? Because I think that might help you a little bit. Because in the book it does say, it says
Yeah, it sounds like it
the
says in the
solutions,
book.
even if the types of solute particles or two different solutions or whatever, if one solution has a greater concentration of solute particles and therefore a greater osmotic pressure than another, the first solution is said to be hyperosmotic. And so that's why I was confused, because it says the osmotic pressure, but I didn't understand the penetrating thing. So like, because glucose can go in and out of the cell, it doesn't, like, because glucose can go in and out of the cell doesn't need to either grow or shrink, because glucose is coming in and out until it reaches equilibrium all on its own. And that's why it can be isotonic, so the cell won't change size, but it can be hyperosmotic or hypoosmotic, because there are a different amount of particles at the beginning before it reaches equilibrium. There's more particles on the outside than on the inside. I don't know if that makes any sense at all, but that was
So,
why I was
okay.
confused.
So Manny, see all those pens that you have in your hand?
Yeah.
Well, on the table, can you put them all in your hand? Okay?
Okay.
All of them in one hand. Okay? So you got 4 in one hand.
Alright.
I've got 2 in one hand. Which solution, if these were solutions and these were the particles, which solution has more osmoles or more particles in it?
This one.
Yours. So is yours hyperosmotic or hypoosmotic or isoosmotic?
Be hyper.
Hyperosmotic, more particles.
Right.
Okay? So when we take so if we're referring to a cell, then we can talk about tonicity. Okay? So if your hand was the solution and my hand was the cell, so the solution has 4 particles, the cell has 2 particles. I put the cell inside that solution. What is that solution? Hyperosmotic, hypertonic, hypotonic, or isotonic?
Would be hypertonic.
Hypertonic, because the water flows out. So it was both hypertonic and hyperosmotic. One was referring to the number of particles. One was referring to what happens to the cell because of osmosis. Okay? So So 0.9% NaCl is like having the same number of markers in here in both places. If I said 6%, so if I said 5.5% glucose,
It would be the same as the isotonic.
so it's isoosmotic and isotonic. But if I said it was 7% glucose, so a lot more glucose out here, who has more pens?
The outside.
The outside. So that has to do with,
Hyperosmotic.
so that is hyperosmotic. But when we talk about tonicity, we're going to say, okay, what happens to the cell in this solution? We know that glucose is penetrating, so it's going to diffuse. So what's halfway between 0.5 and 7%?
2.5.
Well, yeah, it's not perfect, but it's a gist, okay? So we're going to say, so it diffuses, so it's 3.5 and 3.5. So the tonicity is the same because the water doesn't leave the cell or go into the cell. It stays the same. So the tonicity stayed the same even though the osmolarity is different.
Okay. Can get a little bit better.
Okay?
Yeah.
Do you want time to mull it over, or do you want me to go over it again, or do you want to try explaining it?
Okay. So I'm trying to explain.
Okay.
So basically, I'm gonna explain basically what how would you define these three terms, like in one? The osmotic pressure?
So not osmotic pressure.
Osmotic. Yeah,
Or you want me to define osmotic pressure as well?
Like if I want to say like, these three terms are is this. So osmotic, hyperosmotic, and hypoosmotic are osmolarity.
Mm-hmm.
That's osmolarity.
Yeah.
Okay. So the osmolarity is isosmotic, hyperosmotic, and hyposmotic.
Mm-hmm.
In this case,
Give me numbers that you want.
let's see, 10 and 10. 10 NaCl and okay, so in this case, the outside would be hyperosmotic because the solution there's a greater concentration outside.
Greater number of particles.
Greater number of particles
Mhm.
than inside the cell.
Correct.
So that's why it's hyperosmotic. And then the cell would be a hypertonic because it would leave.
Because the water leaves. What if I said this was 0.9?
Then
What is what is the osmolarity and what is the
the osmolarity would be still
osmotic?
hyperosmotic, and the tonicity would be isotonic.
Correct. What if I said 0.001?
Then it'd be hypoosmotic on the outside. The osmolarity,
Probably, yeah.
The osmolarity would be hypoosmotic, and the inside would be hypotonic.
So hypotonic being correct. Osmotic, sorry, this was a tricky one because I didn't change this number. It probably would be hyper osmotic just because there's 10% glucose and all of these are 0.9, 0.5.
Okay.
But that was a hard example just because I was focusing you on this.
Numbers, right.
But you got the principle.
Why does glucose because glucose is penetrating, so you can come in.
Uh-huh. So it doesn't affect tenacity, but it affects osmolarity.
Okay.
Okay? So something that's penetrating doesn't affect tenacity, but it does affect osmolarity. Okay?
Cool.